Hi there, my name is Job Daniel Martin M. Solarde, and today we're going to do an experiment for Science 806. The title of the experiment is Magnetism. The materials we're going to need are as follows: a bar magnet, a horseshoe magnet, another bar magnet, extra magnets, iron filings, and a sheet of plastic. Okay, so what we're gonna do is we're gonna put a bar magnet. Okay, so the iron filings is here, and then we're gonna put bar magnet. We're not gonna put the iron filings on the magnet, so we're gonna put a sheet of plastic on the magnet, like this. You can see. And then we're gonna gently sprinkle the iron filings over the bar magnet. To form a display of what the magnetic field of the bar magnet looks like. Okay, so if we're gonna draw it, it looks like a lot of spokes here and here. So this is what it looks like here. So if we're gonna look at it in the camera, I'll just point it here. There. Okay, so if we're gonna look at the horseshoe, what we're gonna do is we're gonna have to return the iron filings back to the container. So remove the bar magnet. And then we're gonna put the iron filings here. Now, why is the bar magnet on there? Okay, here's the horseshoe magnet. This is what it looks like, a horseshoe magnet. We're gonna place it like that, or like this, whatever. Then we're gonna put the sheet of plastic like in the bar magnet, and we're gonna sprinkle again the iron filings over the container, supposedly over the poles. Okay, we're gonna hold it. We're gonna sprinkle all over the bar magnet. There. Wait. And this is what the magnetic field of a bar magnet looks like. Okay, so we're gonna draw it on the life pack. It looks like spokes. There are spokes in the horseshoe magnet, and then lines that connect the two poles. Okay. Then the next is north pole. So we're gonna use the 2-bar magnet for this one, which is north. Oh, it's hard to tell which is north now because there's no label. I don't know. We'll just use the horseshoe magnet and the bar magnet because it has a label. North and north. There. Cannot be seen. Whoop. They deflect each other. Okay, so we're gonna put the iron filings again on the piece of paper. Careful not to spill it. Might spill. Okay, then we're gonna put the opposing poles and magnet. We're gonna put the sheet of plastic over. Then we're gonna sprinkle the iron filings on top of the two deflecting poles. Okay, so when you look at it, it looks like they deflect each other, and then there's on the opposing poles, on the poles there are the connection, I don't know what you call it, so it looks something like this. Okay, then we're gonna do now north to south pole. Okay, move the magnet, put the iron filings into the paper, put south and north together. Of course, naturally they will attract. Wait. Then put the on top, and then sprinkle the iron filings. Making use. Okay, so what happens is, if you draw it, of course the connecting pole lines, the spokes, connecting pole lines again. But something else happens at the north to south joint. It doesn't deflect each other, it attracts each other, the lines. Form something like this. Okay, so I put the extra magnet so that we can look at their magnetic fields too. And these are called donut magnets, because they look like donuts. This is south and south, so they deflect each other. Oops. We're gonna put it again on the piece of paper, so that we can see the magnetic field. We'll sprinkle the iron filings. Wow, I didn't expect that, but the magnets came with the iron filings, even if it was with the plastic. Gosh. Okay, so this is what it looks like. I don't have to. Wait, there. There's a hole in the middle, then the spokes coming out. Okay. When we try to move, wow! You should have seen it. There. You can see the attraction of the two poles here. There in the middle of the two magnets. If you remove the two of them, check it, and then put the magnet again. So let's say I will take this and put the iron filings on the magnet, on the plastic over the magnet. And when you put them close to each other, if you move iron filings close to each other, they form a line, some sort, like right there. And it, as I said, like poles do not attract each other. They repel each other. So, when you try to put the north and north together, they repel each other. If you put the south and south together, they also repel each other as they are like they have like poles. Unlike poles attract each other. And for example, north and south. North and south they will attract each other. South and north, they will attract each other. It's just basically the same. As a bonus, I got something, a stick or rod, and place it there. Just hold it. Then put the donut magnet through. So when you drop it, okay. Oops. Wait, got stuck in the label. Okay, I just invert it. You see, it doesn't even stick. This is how maglev works because they are like poles, so they do not attract each other. If you move it upwards, the magnet will go flying out because it doesn't like. But if you invert it north to south, it sticks. Unlike poles. How about the North Pole and North Pole? Still the same. It does not attract each other. It works with maglev trains. All magnets with like poles, whatever magnet you use, like poles always do not always repel each other, and unlike poles always attract each other. You see, do like this, and then it just flies off. Okay.